What's up, Algebra? I can write and graph inequalities. I gotta be honest, I think some of y'all have done some of this and you'll just fly through this because you're kind of a pro at, words and numbers. But, then there's guys like me who sometimes they get a little confused. And so it would be helpful if they had something like this to where they can go less than. Okay, so when in English we say that he or it is less than 3, then we can write it like this. The number of y is smaller than 5. He has some chickens and he has fewer than 10 chickens. The temperature fell below 99 degrees. The location, which of the hill, is under 10 miles away, something like that. And if you're like, dude, I can totally do all this stuff, that's great. But one of the reasons why I have this is down here, these can be a little bit confusing. And in fact, I have to apologize. When I made this, I made some copy paste errors, and I had, I think, more than here and here, and that's not gonna work because this is just regular old greater than, and this is greater than or equal to. So I polished this up a little bit. Hopefully it works out a little bit better. I'm just gonna run through these real quick. Greater than, okay, so the size of the building is greater than 100 stories tall. The dog is larger than 20 other dogs put together. I don't know. His winnings were over $50, and we have watermelons more than the next 100 stores combined. That was so stupid, but I'm just trying to give you a quick example. All right, so now this whole equal to portion, it is less than or equal to. So this is like combining the less than symbol and the equal symbol, and voila, they come up with that. So the rocket has no more than 5 astronauts on it. The rocket has no greater than 5 astronauts on it. And by the way, if you're sitting here going, well, wait a second, that says greater than. Doesn't that say greater than? It does. But what I like about this and why I feel like I polished this a little bit is no. It says no. So if we were to say more than or greater than, it would look like this, right? But now it's no more than, right? So it's got to be less than, okay? And then when it says no more than, that's when we can go ahead and include that number. It's not more than that. We can include that. So at most, there's going to be 10 people at the party. So there could be 2 people, 3 people, 5 people, whatever. Maximum, the pool's capacity is 100. So there's got to be less than or equal to 100 people. And you know what I said? I polished it, and check this out. Maximum. I'm doing great, guys. I am doing great. Greater than or equal to, no less than. So it's not less than, it's no less than. So the pool has no less than 10 people inside. So there's easily more. There could be 10 people, but there's more than 10 people. There's no fewer than 6 turtles in the race. So there could be 6, but there is no fewer than that. The number of slices of pizza is at least 4 in every pizza. It's going to be at least 4, so the 4 is involved, but it could be 1,000 pieces. And then the minimum number of pieces of candy in the bag is 12. There is at least 12. There could be more. So I think you maybe get it now. Maybe I did a little bit better job, polished, other than, again, my spelling. So let's slide over here. A number X. By the way, they're being a little nicer to you than in the past, and they've told you the name of the number. It's X. Plus 10 is more than 2, is more than 2. Actually, hang on, I'm going to go with is more than 2 because it could not include 2, right? So let's see, if we were to go over here, there it is, greater than is more than 2, okay? And yes, I do have a typo even on the answer sheet. This one is not mine, so I can't change it, but this one was mine, so I was able to change it. Okay, 12 is no less than. So, okay, I was thinking 12 is less than, but then I said, no, it is not less than. It's the opposite of less than. And if you need me to run through that again, there's less than, but then no less than is the opposite, okay? Slide over here and check that out. No less than, there it is, cool. Greater than or equal to is what that says right there, all right? 12 is no less than the sum of a number and 3, and plus 3, there it is. 1/2 of a number p, 1/2 p is at least, okay, so at least 100 people are there. Well, let me double check it. Like I said, I think you could probably have done some of this without me, without the little cheat sheet, but here we go. Is at least, there it is, greater than or equal to, so is at least. There are at least 100, and I try and put it through this whole little sentence of there is at least, what did I say? I think there was at least 4 slices of pizza, and there it is. So half of a number is at least 100. Okay, keep going. 6 is, and then I love this one, is greater than or equal to. Greater than or equal to the quotient of a number y and 2.5. There we go. Now, down here, what I did is I used this as an example to just remind you that when you multiply or divide by a negative, you flip the inequality symbol. So if it was this, you would flip it to this. If it was this, you would flip it to this. And so here's what I'm going to do. I'm going to go ahead and do this problem the way that it's intended, and then I'm going to come down here and apply this to it. So here we go. I'm going to write it in red. The intended way is right now. You ready for the intended way? Because all we're supposed to do is plug this in, okay? So here we go. -5 is less than or equal to -2/3. Now, why did I put the 2 in parentheses? Just because I'm trying to communicate that, look, I plugged in that 2 just now. And we could simplify this side. I don't really think you need to because you're just looking at it. And then the question is this number less than or equal to this number? And if you're a little confused, why don't I show you a number line? Here's the number line. Let's put 0 there. We don't really need numbers over here because we're only dealing with negatives, right? And here's -5. -2/3 is close to 1, right? -1. It's actually going to be in between 0 and 1, right? It's going to be like right here. So here we go. We have -2/3. We have -5. Is -5 less than this one? It sure is. So this is, yes, this one is true. We nailed it. But now, here's what I'm going to do. I want to go down here. -5 is less than or equal to -z/3. We want to solve this. Like, you know what? I want to know exactly what number, like how this would go on a number line. So here's what I'm going to do. I'm going to solve it. And how would you solve it? Well, I need to multiply both sides by +3. So what'll happen is on the right side, the negative and the 3 cancel. And on the right side, I just have z left behind, okay? And then on the left side, I have +15 now. But here's where this happens. I have chosen, I multiplied by -3, and so I've flipped this around to now it looks like this. And in fact, it feels best to write the variable first. So this is probably the way to do it. Z is less than or equal to 15, because it just feels a little bit stranger to say 15 is greater than or equal to Z. Maybe it doesn't feel worse, but to interpret it, just whatever. So these represent all of the numbers that accurately describe this. Okay? So literally every number that if we were to plug it in, as long as it is 15 or smaller, it will satisfy this. Okay? So if I were to, let's try it, actually. Let's take 15. In fact, we'll do it down here just because we have some room. -5 less than or equal to. Okay, so let's plug in 15 over 3. And then again, we can just kind of simplify this. It's -5. Okay, check this out. Is -5 less than or equal to -5? It sure is. Okay, so in the graphing of this, we had 0, we had -2/3, we had -1, we had -5. But check this out. I'm going to count by 5s, 5, 10, 15, 20. Every number that is less than or equal to 15 satisfies this equation, okay? It would make this number bigger than that. Okay, bigger or equal. If you're feeling a little confused, if you're like, why is there so much stuff on this one problem? I did it the intended way. We plugged it in and we were just fine. I just wanted to remind you that if this is something you need to do, if you plan on solving it yourself, then you need to flip the inequality whenever you multiply or divide by negative. So what does that not mean? It doesn't mean that if I were to plug in, switching colors here, it doesn't mean if I plug in a number. So check this out. I'm going to plug in this number, 21 greater than or equal to -4 times -6 plus 3. Okay? So 21 is greater than or equal to 24 plus 3. So it's 21 is greater than or equal to 27. This is just not true. It does not work, okay? And so we would circle it. Now, if we wanted to solve it, okay, this is like okay, now prove it. Another step forward. 21 is greater than -4t plus 3. 21 is greater than or equal to -4t plus 3. Okay, we're going to solve it. So up here, we did not flip because we did not multiply or divide by a negative. We just plugged in. But here, we are about to divide by a negative. So it's 18 is greater than or equal to -4t. We are going to divide by -4. We are solving. We have now flipped this to be, oh gosh, that's not a whole number, is it? So let's see, that is 4.5, I think. And check this out. I should put it in pink. That flipped, right? And just because I like to write it this way, the variable on the left. Okay, so check this out. Here's the number line. There's 0. What was the number we plugged in? I've already forgotten. We plugged in -6, and we said it didn't work. Okay, so let's count by 2s. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so what we said a second ago was that -6 didn't, where are we at? -6 didn't work, right? So over here, -6 did not work, right? No. Frowny face. But we are saying that any number greater than or equal to -4.5. So here's -5. -4.5 is right here. any number greater than that would work. All numbers bigger than -4.5 would work. So let's try that out. Pick a number that's bigger. Oh, how about 0? If we take this 0 and plug it in here, that should now be a true statement, right? So, okay, 21 is greater than or equal to -4 times 0 plus 3. All right, 21 is, whoa, my pen for some reason went crazy. Is 21 greater than or equal to 3? Yes, it sure is. That's a smiley face. Maybe I'll just do a check mark, right? Okay, but what if we put in another negative number? What if we put in -1, okay? So 21 is greater than or equal to -4 times -1 plus 3. 21 greater than or equal to, that's now +4. Is 21 greater than or equal to 7? It sure is. So that's why that is, we didn't pick it because earlier we used -6 on their advice, right? But I'm just showing you that I solved it. I did that right here. I solved it, okay? And I know that every number from -4.5 up solves it, works. Great. That's just great. We got it. Now let's just keep it simple and just plug these in. Let's do less work. Less work is better, I think, right? So we're going to take a 5. 10 over 5, is that greater than or equal to 1? Well, 10 over 5 is 2. Is 2 greater than or equal to 1? Yes, it is. Oh, by the way, I guess we could check our answers over here. There was yes, no. Well, what did we get so far? We got yes, no. We're shooting 100. Great. Okay, now we can still, all we're doing is we are plugging in a is 3. -9 divided by 3 times 3, is that greater than -2? Well, okay. -9 divided by 9 is -1. And believe it or not, -1 is bigger than -2. And this is where I try and, like, if you're like, what, how's that bigger? Think of it in terms of money. If you owe $1, and then this guy owes $2. Who owes more? Who has the most negative number? This guy. So it is definitely less than this one. And in fact, well, wait a second, that says greater. Yeah, so if this one is less, then this one is greater, right? Anyway, it's however you think of it. If you want to think of it on a number line, which is how, I mean, honestly, that's how we do a lot of this stuff, is we talk about number lines, and then just put it on a number line. So here we go. Here's a number line. There's 0, there's -1, there's -2. -2, -1. If you are closer to 0, then you are greater, just like we were saying here. Okay. Number 9, let's plug in -2. 12 is less than 18 over 3 times -2. Oh, don't forget the plus 12. 12 is less than 18 over -6 is -3. Oh, I forgot my plus 12 again. Plus 12. But you know what? I don't think it's going to matter because 12 is not less than 9. No. Let's plug in 4. 4 times 4 over 8 plus 3. Is that less than or equal to 2? I'm going to switch colors here. 16 over 8. That's 2. 2 plus 3 is 5. 5 is not, I was going to write not, is not less. Okay, so this one right here kind of bugs me because I know what the answer looks like, but here's how I want to write it. The winning team has 245. The other team earns 72 points less. So I'm thinking they earned at least 72 points less. So it would look like this. and then this is how many points they scored, right? They could have earned 73 points less and whatnot. But we were to go look at how the answer is written, here's how they have it written. They've rearranged it. They've done 245 minus some points is going to be at least 72 points. So what's the difference in these? This one is me saying the winner, if we take 72 points away from him, then that score is going to be what the other team's got, okay? But this one says, hey, listen, 245, if we subtract what the other team scored, they've got more than 72 points difference. So if you're like, what the heck is he talking about? There was the answers, right? So then now let's jump over here and let's just do the part B and see what it says. Was one of the teams able to earn 180 points? Explain. So let's plug in 180 here and 180 here and see if it makes any sense. So first of all, 275 minus 72, 245 minus 72. This is 17, right? Yeah. So 173, is that greater than or equal to 180? And the answer is no. Same thing with over here. If we were to just do 245 minus 180, well, that would be 65. Yep. Is that greater than or equal to 72? And the answer is still no. So see how it tracks over here? No, 180 is not less than 173. And that's what this version said, right? So there's a little bit of interpretation to it. And if you're like, you know what, I still don't see how these can be the same. Well, let's take a look at that real quick, shall we? I'm going to copy just this red one and move it down. So I'm going to zoom out. I'm going to grab that problem. Let's go down here and check it out. I can rearrange it to make it look like the blue one. Basically, I'm going to move 72 points to the other team. 245. If I were to give the other team 72 points, then, they scored less than 245, right? But here's how they set it up. They're like, no, let's go ahead and move the other team's score over here, right? And it looks like this. Come on, I'm trying to switch colors here. It would be 245 minus x. So check it out. That is what it says right there. I prefer this one, but whatever. Let's move on, shall we? Graph the inequality. Okay, let's do some graphing. First things first, number line. Mr. McMath really he likes to do this. If he doesn't know what he's going to be graphing, he makes a really long line and he puts 0 right in the middle, and then he starts to read the problem. If he already kind of knows, and he knows it's going to be like super positive, he might put a 0 there, and then 100, and then 200, and 300, because it's going to be really big in that direction. If he knows it's going to be really negative, he might put 0 there, and then negative 10, negative 20, negative 30. You get the idea. But we're about to do number 12 that involves negative 2. So how about this? Why don't we just do negative 1, negative 2, negative 3, and then a 1, okay? So we've got the positive side of the line covered. We've got the negative side of the line covered. And now we are interpreting negative 2 is bigger than k. All right. So negative 2 is our number, and it is bigger than the other numbers. How do I know it's bigger? Because this thing is eating it, right? That's kind of our old school third grade version of inequalities. Negative 2 is being eaten, so it must be bigger. So then that means we're going to shade this direction, because all of these numbers are less than negative 2, okay? And if you're like, I don't really get that, then plug in one of those numbers. Take negative 3, for example. Is negative 2 bigger than negative 3? Yes, it sure is, right? So the other thing to point out is this right here, this equal to portion, says that, yes, we 100% can use -2. Like, we hit it. Like, if we were playing Battleship, we hit -2 because of the equal to part. And when you have a hit in Battleship, you make a filled in circle. You don't just hit it, you fill that sucker in because you actually hit it. Now over here with this one, there is not, that's not there, right? Look, I'm gonna erase it, it's not there. So then we will use an open circle because we can't use -4. We don't actually hit -4. And if you're like, what the heck does he mean by hitting? Again, here's my number line. All right. -4 is on the graph. Let's ask the question. Is -4 less than -4? No. But if we were to go just a little bit more negative, -4, is that less than, hold up, I guess we technically need to go a little more positive because we're trying to say -4 is smaller, right? Because our alligator is eating this guy, right? So actually, I guess I just put little fangs. So it's a vampire, right? Okay, so let's try another number. Is -2. Is -4 less than -2? And it's yes, right? So we know that this guy works. So we're going to shade towards him. Okay? All of these numbers are bigger than -4. Also, all of these -4 is less than all of these numbers. Okay? Now, this is where I'd kind of mentioned in class, I have a stupid way of remembering some of this stuff. Not like the filled in one, not the open circle. I feel like you guys always get that stuff. But now, how about the graphing, or the shading? Here we go. This is how it looks. We have -3.5, which is right here. And it's filled in because of the equal to part, right? Once upon a time, I had a student tell me, like, hey, listen, those are just arrows. You just shade in the direction the arrow is pointing. And I was like, nah, that can't be true. Because look, over here, this arrow, if it were called an arrow, is pointing left. And notice it's shaded to the right. Same thing over here. This arrow, hang on, let me zoom up and out and up. This arrow is pointing to the right, and again, we did not go to the right. So here was that kid's solution. He said, listen, when the variable is on the left, it's an arrow and it works perfectly. And he was right. And I can't let that go because that dude was right, and it's crazy. So anyway, let's follow, oh, you know what, we can't follow it here because we need to simplify that bad boy. We need to multiply both sides by -1. And when we multiply by -1, we need to flip the inequality. So here we go. I mean, it's still going to be that whole stupid arrow conversation, right? Because check it out. We can put an open dot on -3 and we can fill this direction, right? In the direction that the arrow is pointing. But here's what I need you to do because y'all are honors algebra and you know this stuff. Y is the numbers that are greater than -3. These numbers are greater than -3. 16. In fact, if you want to, if you like that arrow concept so much, then rearrange things to where you have to think less. And you go, oh, here we go, 0, -1, 1. And 1/3 is right here, and it's going to be a filled in circle, and we're pointing to the left. Because guess what? 0 is less than 1/3, and so are all these numbers way over here. 17, they throw a little bit of absolute value action at you. All you need to do is simplify this part. And by the way, the absolute value of negative 4 is 4. And that negative, I made it red because it's still out there. And so it's not like it's a crazy problem. Open circle, shade the numbers that are less than negative 4. Yeah? Yeah. Now we're doing the opposite. Write an inequality that represents it. Okay. N is going to be less than negative 2. That's it. N is the numbers, these numbers, because that's where it's shaded. It's going to be less than. It's going that way. Negative 2 is the number that it is, and it's open. We do not have an equal to sign. That's it. That's the whole thing. N is greater than or equal to 1. So here's what we got. N is the numbers. These are the numbers. They're greater than. They're going that way. They're filled in, so it's equal to. It's 1, so that's 1. Hopefully 18 and 19 did not blow your mind. 20, a rectangle has a length of x units and a width of 16 units. So first of all, I'm just going to pause, and I am a big fan of draw the picture, especially if you're a little lost. A length of x units. And you know what? If you're like, wait, I put them on the other side. Cool. As long as you are consistent, you'll be fine. So there it is. In fact, here I'll even label that W. W for length. I'm sorry, W for width, and X for length. There we go. Write an inequality that represents the possible values of X that would make the area at least 112 square units. I like this. It's going to be 16X because the area of a rectangle is length times width. That times that, right? And it has to be at least 112. And if you're like, wait, it's been a long time since we talked about at least. Let's go over here and look. At least. There we go. Greater than or equal to. At least, right? And again, I kind of looked at it as the area has to be, it could be 112. That's the least it could be, but it's probably going to be more. Now it says write an inequality that represents the possible values of x that would make the area of the rectangle at most 320. Okay? 16x is less than or equal to 320. It can be 320. That's the most it could be. This is the greatest. We want it to be less than, though. Less than or equal to. And last but not least, interpret what these inequalities are saying in terms of the rectangle. So this first one, it's saying that the area is greater than 80. And this one, I'll do it in blue, the area is less than 256. If you want to see what did the answer say, the area is at least, and there we go. So I maybe went overboard in some of these explanations, but hopefully if you made it this far, you feel super confident and super okay about all this, and I'll see you later.